Hey guys, this is going to be a quick video just going over how to factor out a GCF from a polynomial and then writing down what you are left with to get your final factored answer. So to begin, you will notice in the first problem it says x to the sixth plus x to the fourth minus x squared. What we need to do is remove from all three of those terms the greatest common factor. The way you do this is you first look at the coefficients of all three terms. The coefficients of all three of these terms is the number 1. And the greatest common factor of the number 1 is 1. So really, we don't even have to write down the number 1 because 1 times anything is itself. The main thing, though, is that you'll notice in our variables the greatest amount of x's that we could remove from all three of these terms is an x squared. That's the greatest common factor of these three terms, x to the second power. And I think it'll make a little more sense where we now write down our remaining trinomial as our factored form. When you remove x squared from x to the sixth, you are essentially taking x to the sixth power and you are dividing it by x squared. That's what happens when you remove a GCF. When you divide two bases that are the same, you just subtract the exponents. And 6 minus 2 is 4. So your result when you remove x squared is that you're left with an x4. The x to the sixth power became x to the fourth power when we removed the x squared as the GCF. Moving things along though, x to the fourth right here in the middle, when you remove the GCF of x squared, again, you're just doing x to the fourth and you are dividing it by x squared. But again, you're just subtracting because when you divide two bases that are the same, you subtract the exponents, so you're left with an x squared. Lastly, there is a negative 1 that is left when you factor out the x squared term from the negative x squared that you see right there. Keep in mind, there is a negative 1 that is represented by the negative sign in front of the x squared. And since the negative 1 is still left over when you remove the x squared term, that's the only thing that's left to be written down as part of that final answer. So what you see here is the factored form of this polynomial. That's what we just did. We factored it. And here's the way that you can check to make sure your answer is correct. Just use the distributive property and multiply your GCF back into the trinomial and you will get the original expression. X squared times x to the fourth, well, again, when you multiply two bases that are the same, you just add the exponents together. So that would leave you with an x to the power of 6, which you can see right there. And then x squared times x squared, again, just add the exponents and you get x to the fourth power. And then lastly, x squared times negative 1 is negative x squared. That just confirms that what we did circled in yellow is the correct answer. You can always use the distributive property to check and see if you get the original expression. Moving on to number 2, examine the fact that we have an 8 and a 32. The GCF of 8 and 32 is just the number 8. And then we have, again, some exponents on some variables. To figure out the amount of m's that you can remove from both of these terms, just take a look at how many m's are in both of these terms. The first term has 3 m's. The second term only has 1 m. What is the greatest number of m's that you can remove from both of these terms? Well, only 1. Because the 32mn squared only has 1m to be factored out. We cannot factor out 3m's because 32mn squared only had 1m to give. So that's why the GCF would just be 8m, but you do the same thing with your n variable. What is the largest number of n's that we could take from both of these terms as our GCF? Well, just look at the smallest exponent, n2. You can only take a maximum of 2 n's from both of these terms. Again, just write down what you are left with inside of the parentheses. 8 divided by 8 is simply 1, which you don't really need to write down because we're multiplying. M cubed, when you factor out an m1, leaves you with only m2. And then n4, when you divide out n squared, you're left with n2. So again, just remember, we're taking m cubed and we are dividing out an m1. And whenever you divide two bases that are the same, you just subtract the exponents. m3 divided by m1 is just going to be m2. Lastly, the 32. When you divide 32 by 8, you get 4. But notice, m is being divided out, and there was only one m to give. N squared was being divided out, and there is only an n squared to give. So that means this is our final answer. But you can again check that this is correct by just using the distributive property to multiply the GCF of 8m n squared back into the polynomial. And 8 times 1 is 8. m1 times m2 is m3. N squared times n squared is n to the 4th. And then now look at your second term, the plus 4. 8 times 4 is 32. But since there weren't any variables to multiply your m and n with, then you just bring along the m1 and the n2, and that's the final answer. In part 3, you first need to simplify, and then you can factor out the GCF. So to begin, you need to use the distributive property to multiply the 6c and the negative c into your polynomial. 6 times 2 is 12. And c1 times c2 is c3. 6 times negative 4 is negative 24. But because there is a c right here and no c with the number 4, the c that you notice right there just tags along. Next, negative c is multiplying 8c. So the only thing that really gets multiplied together is the fact that you have a c multiplying another c. c1 times c1 is c squared. Now that we have our trinomial, which you could rearrange into standard form by just flipping those terms, however, I ran out of room on this slide, so I didn't bother doing that. You're now ready to factor out your GCF just like we did in problems 1 and 2. So you have a 12, a 24, and an 8. The greatest common factor of those three numbers is the number 4. And then, again, look for the smallest exponent that is in one of your terms, because that is the most amount of that variable that you could take. How many c's do we need to remove from all three of these terms? Well, in the middle term, we have a c1. And since c1 is the smallest number of c's in this trinomial, that has to be the GCF that we could remove. So what are we left with? 12 divided by 4 is 3, and c3 divided by c1 is c2. 24 divided by 4 is negative 6, and there was a c1, but we divided out another c1, so we're just left with negative 6. Negative 8 divided by 4 is negative 2, and c squared divided by c1 is just c. So there you have it. Again, you could put this into standard form by just flipping those last two terms around. Last one, number 4. Again, use the distributive property to first simplify your expression. Negative t times t, negative t squared. Negative t times 4 is negative 4t. And then t times 4t squared is 4t cubed. T times negative 2 is negative 2t. Next, we have to rewrite this in standard form, which I did do this time because I designed it to have enough room. You have like terms right there, but your 4t cubed has to be written down first because it has the highest exponent, that being a 3, and then a negative t squared, and then negative 4t minus 2t is negative 6t. You now have your trinomial that you are able to factor with, and you need to now take out your GCF. Notice we have a 4, a negative 1, and then a negative 6. The greatest common factor in that case would just be the number 1. But 1 times anything is itself, and we actually don't need to write that down. So we can simply look at our variables. What is the most number of t's that you could take from all three terms? Your last term has a negative 6t, so that means you can only take a single t from all three of these terms. 4t cubed will become 4t squared because you removed one t. Negative t squared becomes negative t, and negative 6t just becomes negative 6. Alright guys, I hope this at least helps you get your homework started. I'll be available in the mornings if you need any help. The homework is due on Friday. I will see you later.